Hello, mathletes. How you doing? This is Mr. Muscarella coming at you. And in this video, we're going to take a look at Super FRQ question 5c. Now, in question 5c, we're being asked to find all values where all values of x, where g is a horizontal tangent, determine whether a relative min, max, or neither is occurring at these values, and of course, justify our answers. So anytime we want values of x where g has a horizontal tangent, and g is defined by our function down here. So that means I want g prime of x to have a value of 0, which means really that's the same thing as saying where is f of x going to be 0. So if I look on my graph, that's going to occur at several different spots. I can see that it is going to occur at -3. I can see that I'm going to have a y value of 0 here at 1 and also here at 4. So I'm going to look at those couple of pieces. So those where my horizontal tangents are. The next part says, do we have a max? Do we have a min? So to analyze that, what we're going to do is just look at what happens to the y values on each side of those corresponding x values. So at -3, I'm above the x-axis, which means my y values are positive. On the other side of -3, I'm below the x-axis for my values, which means my function has changed from a positive to a negative. So if we are increasing and then decreasing, that value right there is going to be a max. That's going to be a relative max. Now, if I look over at x equals 1, I'm below the x-axis on the left side, and then I change and I go above the x-axis on the other side of 1. So if I change from a decreasing to an increasing for a function, then that means this spot right here, I'm going to have a minimum, yep. And then lastly, but not leastly, we are going to look at x equals 4. And on the left side, I'm above the x-axis for my y values, and on the right side, we are below. So again, I've got a sign change, and my y values change from positive to negative, which means, so if I'm going from positive to negative, that's going to be a max right there. So that's basically all you need to do for this problem is analyze the graph, since it's defined to be this, our function g is defined to be the integral, and I want to take a look at where my derivative is 0 or where my y values are 0. And that occurs at x equals -3, 1, and 4. Now, when it comes to justifying our horizontal tangent, you simply just want to state g has a horizontal tangent at x equals -3, x equals 1, and x equals 4, since g prime of x equals 0 at these values. For our relative max or min, there you have to identify whether or not you're going to, where the x value is, and how there's a sign change. Do you go from positive to negative or negative to positive? So the two things you'll need to indicate are where and how. Where the x value is and how the sign of g prime changes. For our relative max, g is going to have a relative max at x equals -3 and 4, so that's the where, since g prime of x changes from positive to negative. That's the y. That explains how g prime changes. Likewise, you're going to have a relative min at x equals 1 because g prime of x changes sign from negative to positive. So again, your where is at x equals 1 and your y is at from negative to positive for the changing of the signs of g prime. Now we don't include the endpoints because remember, the endpoints are only included when when you're looking for an absolute max. So this is going to be coming up here in part D. In part D, we're going to look for an absolute max and an absolute minimum value. So we've got to take a look at these values in addition to our endpoints for part D. So when you are ready, come on back and check out part D, and we will determine absolute maxes and mins for G at any x values that occur. Thanks so much for watching this one. You mathletes have an awesome day, and I'll catch you later. Peace out.